Welcome back to Bite-Sized AI. I'm Michael Barnes. Today we're asking, do giant LLMs like GPT-4 or Claude still rule? Or are smaller domain-specific models quietly taking over for real business? We're talking specialized models trained on industry data or synthetic data, why they often outperform the giants in enterprises, plus huge efficiency wins. Randy, break it down for us.
Happy to, Michael. And honestly, the shift is not just real, it's becoming quite pronounced. For a long time, the narrative was bigger is better with LLMs, right? Everyone was chasing those massive parameter counts. But what we're seeing now, especially in the enterprise space, is a growing realization that while these giant general purpose LLMs are incredible at broad reasoning and creative tasks, for most very specific focused enterprise tasks, they're often just overkill. They can be expensive, sometimes surprisingly slow, and critically, sometimes less accurate or more prone to hallucination when you're deep in a narrow specialized domain.
That's a bold statement, Randy. Less accurate. I mean, we've all been wowed by what the big models can do. So let's get into the nitty-gritty. What exactly is a domain-specific model versus a giant LLM? How do we even define that distinction for our listeners?
Great question, Michael. Think of it this way. A giant LLM like GPT-4 or Claude is trained on internet-scale data. It's seen pretty much everything: books, articles, code, conversations across the entire web. It's designed for general knowledge, broad reasoning, and tackling a huge variety of tasks, from writing poetry to summarizing a news article about astrophysics. It's a generalist, a jack of all trades, and quite frankly, a master of many. But a domain-specific model, often called an SLM or DSLM, a small language model or domain-specific language model, is fundamentally different. These are typically much smaller, usually ranging from maybe 1 billion up to 30 billion parameters, give or take. The key is that they're fine-tuned or sometimes even trained from scratch on highly curated, very specific industry data. We're talking legal contracts, medical records, proprietary financial reports, internal company knowledge bases, specific code bases for a particular language or framework. The data they see is narrow but incredibly deep and relevant to their intended use.
Okay, so the difference is in the training data and the scope, generalists versus specialists. And you mentioned synthetic data earlier. That really caught my ear. How does synthetic data play into training these specialized models? Because traditionally, gathering massive, high-quality, real-world data for niche domains can be a huge bottleneck, right?
Absolutely, Michael. That's precisely where synthetic data becomes a game changer. You hit the nail on the head. Gathering enough high-quality domain-specific data, especially in regulated industries like healthcare or finance, is incredibly challenging and expensive. That's where the bigger LLMs actually loop back in to help. A common strategy now is to use a large, powerful general LLM to generate synthetic data. You might give it a few real-world examples, say 5 to 10 actual legal clauses, and then instruct the giant model to generate thousands or even tens of thousands of new, diverse, yet highly realistic examples tailored to your specific domain. This synthetic data can include variations, edge cases, different phrasings, and specific jargon. You then use this synthetic data set, which is often augmented with a smaller amount of real data, to fine-tune your smaller domain-specific model. The result, you bootstrap a high-quality training set without needing to collect or manually annotate massive amounts of real-world data, drastically reducing development costs and time.
That's brilliant. It's like using the giant LLM as an expert data labeler and generator. So with this focused training and potentially synthetic data helping out, why do these smaller ones often beat the giants on enterprise tasks? What's the secret sauce that makes them superior in their niche?
The secret sauce, Michael, is focus. It truly beats breadth when you need precision. When a model is trained exclusively on legal documents, for example, it doesn't waste its internal neurons trying to understand poetry or scientific papers. Instead, it develops a much deeper, more precise understanding of legal language, its nuances, precedents, rules, and even the subtle implications of specific phrasing. It learns the grammar and logic of that domain in an incredibly detailed way. This specialization means they are much less likely to hallucinate because they're not trying to guess outside their specific expertise. They stick to the facts and patterns they've been trained on. We're seeing benchmarks and real-world deployments show specialized models hitting 25 to 30% higher accuracy in tasks within medicine, law, finance, and specialized customer support compared to general LLMs on those exact same tasks. That's a huge difference when you're talking about business-critical application.
25 to 30% higher accuracy is absolutely massive, especially when errors can have significant financial or even human consequences. Beyond accuracy, you touched on efficiency earlier. Walk us through these efficiency gains. How does going smaller translate into real-world cost savings and performance benefits for businesses?
The efficiency gains are truly massive, Michael, and this is where businesses start to see the ROI really shine. First, let's talk about inference, which is the cost and speed of getting an answer from the model. Because these models are smaller, their computational footprint is significantly reduced. Inference can be anywhere from 5 to 10 times faster, and crucially, up to 90% cheaper per query compared to calling a giant LLM API. Think about that, a tenfold speed up and potentially a 90% cost reduction. That's transformative for businesses. Lower latency means you can use these models in real-time applications where every millisecond counts, like live customer support chats or even on edge devices for specific industrial applications where cloud latency is a non-starter. Furthermore, you can self-host these models. This is huge for privacy and compliance. Companies in finance, healthcare, or government can run these models entirely within their own data centers or private cloud environments, ensuring sensitive data never leaves their control. This addresses major regulatory concerns. Plus, with smaller models, you're looking at much lower energy consumption, which is good for sustainability, and they're much easier to scale for high-volume enterprise workloads without breaking the bank.
That's a compelling argument, Randy. Faster, cheaper, more private, and better for the planet. It sounds like a no-brainer for most enterprise applications. But is there a catch? Any downsides to going small and specialized? Where might these models fall short compared to their larger generalist cousins?
Fair and important point, Michael. They're not a silver bullet for everything. The primary downside is their lack of versatility. A legal model, for instance, isn't going to suddenly write a compelling marketing campaign, generate creative story ideas, or debug random Python code as well as a giant general-purpose LLM. Their expertise is narrow. So if your task requires completely novel creative generation, or if you're tackling highly cross-domain problems that require pulling knowledge from disparate fields, then you may still need the big ones. Or more likely, you'll adopt a hybrid setup, which I think is where a lot of enterprises are heading. You might use a big model for initial brainstorming or complex multimodal tasks, and then feed the results into a specialized model for refinement or specific execution within a given domain. But honestly, for 80% of real business work, things like document summarization, specific code generation, customer inquiry routing, or internal knowledge retrieval, specialized models are absolutely the winning strategy.
80% is a massive slice of the pie. It really highlights the practical application here. Can you give us some more concrete, real-world examples of where these specialized models are already making a tangible difference today?
Absolutely. Let's start with Bloomberg GPT. This is a model specifically trained on vast amounts of financial data, news, filings, reports, etc., and it absolutely crushes general models on finance-specific tasks like sentiment analysis of earnings reports, predicting market trends based on news, or answering complex financial queries. In medicine, we're seeing variants like MedPay-LM, or even smaller open-source models fine-tuned on medical journals and patient data, outperforming general LLMs on diagnostics, medical Q&A, and summarizing clinical notes. For customer support, SLMs are delivering faster, more consistent answers by being trained on a company's specific product manuals, FAQs, and past support tickets, all at a fraction of the API cost of a general model. Even in coding, we're seeing fine-tuned 7B parameter models now rivaling much larger ones on specific languages or frameworks, like generating idiomatic Rust code or highly optimized SQL queries. The specificity leads to superior quality and reliability.
These examples really paint a clear picture for enterprises watching costs, concerned about privacy, and absolutely needing performance and accuracy. It sounds like the landscape is shifting dramatically. So if an enterprise is just starting its AI journey, or maybe even rethinking its current strategy, what's the smart move today? How should they approach this smaller is better philosophy?
The smart move, in my opinion, is to pivot towards a specialized model strategy for core business functions. Start by identifying the specific domain where AI can provide the most value. Then leverage a strong open source base model. There are many fantastic ones emerging that are already powerful, and fine-tune it. This fine-tuning should be done on your own proprietary domain data, or as we discussed, use synthetic data generated by a larger model to augment or even create a high-quality training set. Once fine-tuned, deploy it either on-premise or within your own virtual private cloud. This approach gives you that unbeatable combination, better accuracy and reliability within your domain, significantly lower operational bills, much faster responses, and perhaps most importantly, full data control and privacy. Giant LLMs still have their place, of course, for broad exploration, ideation, or truly general tasks where domain-specific expertise isn't paramount, but the future, Michael, is undoubtedly hybrid. Use the right size, right trained model for the specific job at hand.
That's powerful stuff, Randy. It's a pragmatic and cost-effective approach that every business leader needs to hear. It's not about abandoning the giants, but intelligently integrating specialized tools into the workflow. If you're building enterprise AI or just trying to navigate this incredibly fast-moving landscape, understanding this shift could save you serious money and headaches down the line. It's about optimizing for purpose, not just for raw power.
Exactly. The days of a one-size-fits-all AI model for enterprise are quickly fading. We're moving into an era of highly optimized, purpose-built AI agents. Smaller, smarter, and more efficient is truly the new winning formula for getting real business value from AI.
Couldn't have said it better myself. Randy, thanks for the incredibly clear and insightful breakdown today. Always a pleasure having you on.
Anytime, Michael. Thanks for having me.
That's it for today's Bite-Sized AI. Listeners, we want to hear from you. Are you using domain-specific models yet, or are you sticking with the big generalists? Drop your thoughts in the comments or on social media. Let us know below. Stay efficient, and we'll catch you next time.
I touch you.